I have not done this, so we're doing it live, so there is a chance that, you know, we run into a few problems. But that will be important because at your disposal here is a wealth of code that helps you link data from one software to another. It's available to not only you, but to your competitors. It's open source. So what we're about to show today, if you don't learn it, the guys at other companies are going to learn it because it's literally free, and it comes down to how much you're willing to give it a shot to learn. You need to use this properly. Most likely you need some of the smiley face training, and you need the facade. So it's all interconnected, but what we're about to show is that actually if you're making a finite element model, you have the tools at your disposal, that you don't need to go buy some expensive piece of software because you already have an expensive piece of software called Robot, which does the same calculation. So if I want to talk to another program, that's called an adapter. The BHoM has four main parts. There's objects, OM, engine, which is like algorithms that take in objects and they do work with them. And then there's adapters, which connect the objects to other parts, other software. So today we're going to want to create an adapter. So if you go create adapter and you put it on the canvas, you get this thing that looks like this, right? And what you do is you right click it, and we're going to look for the robot adapter. You see this window that comes down. So everybody should go in there, say create robot adapter. And then all we want to do go adapter, create adapter, drop it down, right click. What's wrong? Is it okay? Do you have this screen? Okay. Then you want to grab a toggle, and we're going to turn this component on by doing true and putting them in here. And what you'll see is actually robot turns on. He says, waiting for robot to show up.
So you should have a robot.
Robot just opened, right? So you just learned, if you did what I just did, you learned how to, instead of double clicking robot to open him up, you learned how to do it via Grasshopper.
Where could we get the component?
Toggle, you double click and you say toggle.
Toggle.
Toggle is a true-false thing.
Okay. Is it different from Boolean toggle? Boolean toggle or toggle?
Boolean toggle is the same thing as toggle. Effectively, if we look here, going back to what we discussed last time, if we look at what this guy wants, he wants a active. What is active? This is a Boolean. A Boolean is true-false. So this guy turns him on and off. It makes him active. So before, if I had just come out here, again, we don't want to go down the rabbit hole of every single component. That's for, really, we should learn that on the job. But if I go and I create a robot adapter, and it's not active, it doesn't open, it didn't open up this robot instance for me, right? So until I turn him on, he actually doesn't open the program.
This was the program.
Because you have to double click the false and it'll turn true. Double click it. Huh?
So we need to open the robot. But it takes some time.
It takes some time to open it up, but it took 26 seconds for me. Now, if we go up to the adapter component here, there are adapters, and then there's stuff that you can do with adapters. So you can, for instance, and these are the main things that you'll need to know about for now. You can push information to the adapter, so give information to robot, or you can pull information away from robot. That's a key thing. Okay, because we're going to keep saying that, push and pull. Right now you're used to going over to the robot screen and typing in stuff. Are we good?
The robot is not installed.
Robot's not installed? Oh, you guys are following along then. It's okay, we're not going to get too far today in terms of hands-on. It's unfortunate. But we didn't know we were going to use robot today. It's okay. Because the more important thing is actually you can still make the script. You guys can still make the script.
All right. Yeah.
Because the script is independent of robot.
Yeah.
You won't be able to have it go to robot. But the more important thing is, okay, great, I don't have robot. So this guy right now will say, let me guess, he's red.
Yeah.
And he says, I don't have robot. So what do you want me to do? He turned red. And that's what he's saying is, hey, what do you want me to do? There's no robot. But it doesn't matter, because what we're going to do is we're going to create a bunch of objects, which again are here. And eventually what we're going to do, again, we're going to push and pull information from here in Grasshopper to robot. We're not going to use robot to create this finite element model. All right? Why? Because we don't know robot, and robot's kind of clunky. All these finite element softwares are difficult. Byongi tells me the only reason people go to this other software is because it's more quote-unquote user-friendly. But all engineering softwares are not user-friendly in comparison to what your phone is, right? So in this situation, I know at the end of the line here, I'm going to want to push. So let's go back to a real quick look at what we'll do globally here. Number one, what do we always start with? Input, output board, right? Because if we actually just do that, we'll save ourselves a lot of headaches, even though it's a pretty easy example. So what's our input? And what's our output? Let's stay simple right now, right? We want to be able to sketch an outer profile of some sort of, I don't know, glass profile. So the first thing's a profile. And next we want to be able to sketch some areas. They could be linear, they could be points, supports. Right? We probably want to be able to put in thickness properties, material properties. And at the back side of it, we want an FEA model with, oops. My trackpad's off. We want that, plus, let's say, some supports, plus, let's say, the supports, and then there's a thickness associated. Okay, so we know that we're going to use the BHoM, so we need to be able to take all of these things and create some sort of BHoM object, and I will tell you, this is called a panel. There's a very high level look at this, and then what are we going to do with that object? We're going to push that object over to robot. All right, so this is the robot adapter, and these BHoM objects are called panels. Okay, you might not know that they're called panels in robot or in BHoM. They might be called something different in robot, but the key is you won't touch robot in this exercise. You'll just touch the BHoM, which means that we're going to have to create the BHoM object, number one, and then we're going to have to push the BHoM objects using the robot adapter to robot. Okay? Let's go over the first part here about creating this panel. I'm telling you right now we have to create a panel. So if we want to create an object, again, an object is an object. It's not another software. It's not an algorithm. You know, it's not 2 + 2. It's the number 2. It's an object, right? It's an integer. We go create object. We zoom in on that. Looks familiar, right? Whenever you start seeing things that look like this, you right click, you go select a method. In this case, we're talking about structural engineering because it's finite elements analysis. So we'll go in here and we'll look for elements. We'll go to panel. Panel, you see how many options there are. So sometimes it can be difficult to find the object that you want just by kind of doing this. But in this situation, we can see a bunch of options for creating a panel. You might see some new terms here. So it says I-curve, I-surface property. Don't be scared by that. Let's just click the first one, which will maybe help us. So if I click this guy, what does he ask for? He asks for an outline, an openings, a property, and a name. Now, from first principles, remember we talked before about first principles versus computational stuff. In terms of what we want, does that make a lot of sense, what it's asking for? Is that the right object? Is a panel the right object based on the inputs? Going back to our sketch here, we have what we call the profile, supports, and thickness. And this guy asks for outlines, openings, properties, and names. So obviously we had 3 things, this guy only has 1. So is this guy right or wrong just by looking at him? Again, we can hover here and we can say it says outline, and it says this thing is a arc, circle, ellipse, line, NURBS curve, polyline. I-curve means many different types of curves. Whenever you see I in front of something, it just means it's a bigger than just a curve. It's any type of curve. This is probably it, right? Because we had said what we want to do is we want to be able to create a profile. In this case, it's called an outline. And we want to be able to give it a property, which we call the thickness of some sort, right? So in this situation, let's just go over here. I'm going to create in Rhino. I'm in meters. You should always work in meters for the BHoM. I'm going to create a 1x1 rectangle here. And actually, I'm going to probably make it a little bit fancy. Let's see if we just sort of chamfer it off here. Trim. You don't have to do this, but you need a closed thing that represents your glass. So that's our glass panel. And let's say, for the sake of argument, that in what we're about to do, I'm going to save this real quick. Analytically, what we're going to want to do here, I'm going to suggest that we say this guy's a knife edge support, and this guy is a pin support. Just relatively, just to get something going, okay? But for now, let's just focus on getting in the panel itself. So everybody follow along here. Create some sort of closed line, curve in Rhino, just like CAD. And everybody let me know when you have that, a closed curve. It should be about 1 meter by 1 meter. Doesn't need to be, but let's make sure it's not 1,000 meters by 1,000 meters. Lily, good? No? Then just make the rectangle. Just make a rectangle. Don't need to get fancy like me. To what? Yeah, because you need to join. So if you want, you just click both of them, middle mouse wheel, and then click join. Just like in CAD. Okay, so one thing, are you good? Does everybody remember how to get this guy into this guy? So go from Rhino to Grasshopper. How do you take this into Grasshopper?
Cool.
How do you do it? We've done it 1,000,000 times. Set one curve, right? Now it's in Grasshopper, right? And if I put him into the outline, it turns green all of a sudden. It's this guy's alive, okay? So everybody get to the point where you've done this on the screen. Okay? I want you to note there's this component up here. Look where my thing is, explode. Even if you double click the canvas and you go explode, explode is your best friend. The explode with this emoji is your best friend. Why? Because it tells you what this thing is. So you look at this and you say BHoM structures elements panel. And you go, what on earth is that? What does that mean? Well, it's an object that inside of it, it has openings, external edges, properties, yada, 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 right? So it's just one object at this point in the script that actually contains all of this stuff. What's more is if you explode, let's say, the edges, there's even more information in there. And if I explode, let's say, the releases, there's nothing in there. The curves, maybe. There you go. So you can start to see why it's so important to understand objects, right? Because actually the panel is made up of all of these things. All of these external edges are made of all of these things. And of those things, you know, it's a tree, right? Does everybody see that? We're not going to go until everybody's at least kind of done this. So, in other words, we've gone from one piece of geometry. We have the ability to add all of this stuff here, but it's not that this panel is just geometry. This panel is more than just geometry. For instance, this property, it's null right now. So let's give it a property. If you go create object, again, everybody has to get used to it. If I want an object, I go to create object, or another way of doing it is Shift Control B, and you can search for it. So in other words, if I want to find a panel, I search panel in Shift Control B. And in this situation, I'd find it again. You could equally right-click this guy and go panel. It's the same window that would come up. So you might not know what thing you're looking for yet, but if you were driven, you could come in here and actually say, well, do I care about acoustic engineering? Definitely not in there, right? I'm in structures, I'm looking for all this stuff. So right now we'd be looking for a property, a section property, and we can just probably follow ourselves to areas of the code that might help us, right? So if I go to section properties here, or rather surface properties, because you could say we have a surface, right? It's not a section of a 1D thing, it's a surface thing. We probably want something that's constant thickness, and boom, right there, look at what it says, constant thickness. If I put that out here, again, you could find this guy, if you knew this is what you wanted, Shift Control B, and then say constant thickness. And the same thing comes up. So multiple access points to the same component, right? And what I'm going to tell you right now is this guy, he actually wants to go to here. He's the property that we want. So remember before, going back to our original sketch, if I can just pull it up real quick. What did we say? We said we have a profile and we have thicknesses. So we've probably covered both of those right now. Between this guy, he's our profile, and these guys' constant thickness is a property. This thickness is a double. What's a double? Double trouble. It's a number, right? Every number you're going to put into the BHoM is newtons, is meters, is whatever other unit, but it's not millimeters, it's not kilonewtons, it's always meters. So in this case, let's make it, I don't know, what's a good thickness for glass?
10 millimeter.
10 millimeters thick, so that's 001. Oops, sorry. Okay, and look, he's happy now. And by the way, everybody's happy because they're not orange. And if I go and explode property, look what just happened. Now property actually, so again, you have to think of this panel element right here. If I just pull out a data bucket, again, data bucket, this is the, one second.
How can I call out constant thickness?
So we were just talking about that. So Shift Control B, you press Shift Control B
Yes.
in the canvas, your cursor has to be here. Shift Control B.
But that calls construction mesh.
Huh? Constant,
The,
I'll come see.
the code is
No. Shift, you're not doing Shift Control B. So you have done this. You've done what we've always done. Double click the canvas, right?
Yeah.
And you've done, yeah, you have to do, that doesn't work. So you got construct mesh because you said constant thickness, and you probably spelled it wrong maybe too because it's not coming up, right? What you want is Shift Control B, then press Shift, then Control, then B, then this window will come up. It's different.
This is only for BHoM.
Yes, bingo, bango. So, or again, I don't like doing it this way because it takes more time. But you go to Create Object up here, Oneling. You drop that, and then you can search here. Again, key important thing for you guys to walk out of here today. If you want to create something in the BHoM, create object right here, or Shift Control B. But Shift Control B implies that you already know what to look for. So I can tell you some of the keywords that you'll need, but a lot of times it's easier to start from here. And the adapter, which will allow you, let's just say for instance, if I can create any adapter that's in this list. So I can push to all these different softwares right now, and that's not even all the softwares that are available to me. For right now, we're focusing in on robot, okay? Another key thing is you're creating objects. You're not creating just, don't ever confuse, 3D models versus, that's an old thing. We used to only deal with objects that were geometry. We're dealing with objects now that have more data than just geometry. So for this panel, what we've just created, which will eventually go to robot, is if I look at him, there's edges, openings, properties. There's a lot of information inside of this guy, but only some of it is geometrical. In fact, an edge, you think of an edge as something geometrical, but actually, even in the edge himself, there's stuff called releases, supports. These things are not geometrical objects, right? So we're not just playing with geometry anymore as engineers. We're playing with hierarchies of data. Now, unless I'm mistaken, and I don't, there's one more thing we should do, is we should finish our job up here, and create this constant thickness with a material and a name, okay? So the name, let's just double click the canvas, not Shift Control B, double click, and I would just put in //10 millimeters. Okay? Everybody got that? And if I wanted a material, where do you guys think we go to find the material? So what's he asking for, first of all? This is an eye material fragment. Boy, that sounds weird, right? That sounds really weird. Let's give it a shot, though. Where do you think we go to find where that is? Based on the conversation we just had, Oneling. What do I do to find out, make a material? Yeah.
Okay.
Where do I look for it in the computer? Where are all the objects?
Rubber.
Huh? Say it again. I can't hear. Where do we find, we just talked about it, where are all the objects, period?
Yeah.
Where are they in Grasshopper?
Bring from right now.
No, not anymore.
Rubber.
Nope, robot, we haven't done anything in robot yet. We're going to create stuff here in Grasshopper and go over to robot with it. So we're creating objects here. So for instance, this thickness object, we've created it here. This panel object, we created it here. So how did we do all that? We did Shift Control B, right? Or the object one. So for material, if I do Shift Control B and I search material, there's a lot of stuff that comes up, right? So I'm going to tell you right now what we're looking for. Let's take a step back. This one isn't going to work. So follow me very closely here. Again, it takes a while to get used to the BHoM, like any other tool. Create object. Everybody go here. Okay, once you have that, right click, select a method. Okay, and I think actually, just give me a second. I think it's actually in physical now. Is it in there? You're the boss, Lily. Good job. Now we only have things that are jumping off the page to us as generic, these fragments. These are concrete, steel, aluminum, timber. So we don't have anything right now that would be like glass. But potentially what we can do, let's see what steel's looking like. I mean, I don't see steel as a linear elastic material. The way we're describing these steel is it has a name, it has a modulus of elasticity, it has a Poisson's ratio, it has a thermal expansion coefficient. What's the difference between that and glass? What variables do glass have that we would want to see here? Maybe we don't have to answer it now. Maybe in the long term we would need to create glass, but for right now, for the purposes of setting up a finite element model and getting out von Mises deflections or stresses and deflections, we could probably throw in here, this one is glass, the name is glass, right? What's the modulus elasticity in glass in pascals? Right. Young's modulus of glass in pascals. Must be right. 72 e to the 9th. Again, everything's in pascals. 1, 2, 3, 1, 2, 3, 1, 2, 3. And just for now, I'm going to leave the rest of them just blank because it doesn't really matter. We're not going for gold here in terms of the absolute best thing ever in the world. This is an example, right? We could fill the rest of these in. But if I take material now, so just fill in something so that he's happy, especially for the name, and then throw in material, and note that now the material, if I explode him, so they've come in here, and look at all that coming out here. So we see glass here, and if I come over here, I should see the name is glass. So I'm showing you these things to remind you that at this point in the script right here, we have so much data. Yes, if I click on him, he turns green, and you might get confused because you'll be like, oh, that means that he's just a curve, right? No, he is way more than just a curve. In fact, most of the information that's on the screen here is non-geometrical information. Does that make sense? Next thing I want you to do is pull over your friend the adapter and follow me while I do this. Robot adapter to adapter. Panel to objects. Okay? And then a toggle to create active. And if you do that, he'll freeze a bit because he's actually sending that stuff from Grasshopper into robot. And if I look at him in robot, he actually has the thickness. You see down here, the thickness is 10 millimeters. It doesn't have any other properties because we didn't put it in there yet. The material property is glass, so that's 72. That 72 is in there. It automatically calculated the shear modulus. But there's stuff in here now that can form the basis of a finite element model. Okay? And we didn't have to touch robot yet. Okay. So that's why the BHoM's important, because all of this is available to you. In fact, because the BHoM is open source, I was able to, before you guys came in here today, I opened up the code, and Byongi was like, we need to put on edge supports, right? So I was able to open this code and actually know, before you even came in the room, in 1 second, is there an ability for us to push panels, let's say. So there is an ability for us to push panels. This is the code that you use when you create a panel that goes over to robot. This is the code. You don't need to know this stuff. But the key is you can come to a guy like me and say, can we push over edge supports, like blade supports? And I can look at this line of code right here and go, yep, we can. We absolutely can. I know that we can just by looking at the code. Okay? Well, you don't need to know this right now. What you need to focus in on is learning all this stuff that we talked today. It already took us an hour to do just the introductory stuff, very basic introductory stuff, which is adapters. Adapters connect to other software. Creation of objects. Okay, so this is BHoM object creation. When we use the BHoM, we are using the BHoM. Okay, so if you want to create a circle, okay, there is a definition. Circle. That right there, and if I double click, if I say circle, do you see these two? This one right here was created by Rhino, and this one right here was created by us, basically, but it's the BHoM, right? Those are not the same thing, and that's why it's really important, the chapter 1 stuff that we were talking about with the smiley faces. If you don't understand, it looks, both of them say circle. In English, they're both the same, but data-wise, they're not, because we could take this circle, and we could actually use him as the outline for a, oh, because I didn't give him a center and a radius, right? So I could do Shift Control B, Shift Control B, Shift Control B. I think I made my Grasshopper angry. Or I could just go old school. Say point. We have a definition for a point. Again, it's not exactly the same as everything else, right? And now it's doing some work, because actually I think it's sending over some sort of other panel. So see how there's 2 panels here now? So if I go to panel, if I delete panel 1, I maximize somewhere. It doesn't have a radius, so let's put in a radius of 2 meters. See if it works. Oh, what did it say? Object reference not set to instance of object. Not sure what that actually means in this situation. Doesn't matter. You're going to have stuff like that. Get used to seeing this. What this actually means is that we didn't give him something that he needs. In this situation, my guess is he's not getting... He doesn't like this. This should be able to work, though. This circle. Property type. Let's try it again. Oh, there we go. It was a bit of a mishap in the way he was communicating with robot. Again, get used to seeing red. It's always the case. Until you know more and more and get more and more practice, it's not going to work. But there you go. There's another panel over here in robot, right? Again, it comes down to understanding objects are created over here, right? Adapters communicating those objects to elsewhere is over here, right? Is the adapters here. And to push and pull stuff is push and pull. And I think another huge part about, just the first part about the objects, is to understand that if you don't understand what something is, that objects themselves are hierarchies. That a circle, in this case, a circle is an object which has a center and a radius. What is the center? The center is a point. What is a point? It is 3 numbers, right? Just as well as you can see these kind of hierarchies forming left to right. If you explode something, you can see them exploded left to right. The tree is getting smaller here. So this is the tree, right? So all of this stuff right here. See how it's kind of in this view, he's kind of funneling. The information itself is funneling here. In the same way, that information, if I take him down here, this is a good shot right here. So to create an object is effectively to compile information into one piece of information. But to explode it means to take it back apart, right? In Grasshopper language, we'd call this construct. And we'd call the other one deconstruct. In this case, it's called, we're just creating stuff, and exploding it. Okay? So that's a big deal because that, as you can see, I highly recommend for the next lessons, if we're going to go over this as our next sort of big investigative thing, which again, there's some huge value here if you're making finite element models to starting to work in this space. We need to show up on time, and we need to come in with a little bit of momentum next time because it only gets, this is where it's extremely useful, but it's also, the learning curve is a lot bigger. And I see already on Byung-Hee's screen that he's got something like this, if I can just replicate what he's got. He's done, actually I'll do it more like you did it. How about that? He's got some spider holes here. Which I don't think we'll have time for today. So the next question we're going to have is if that's our guy, if that's the guy who we want to send over, and we want analytically that edge of that surface right there is going to be pinned or fixed, whatever it ends up being, right? That's the next layer of this. We had said it at the very beginning that the supports are going to be critical. Am I right to say, based on my understanding, that the supports are easily, the nice thing about the other software is it allows you to apply spider supports and stuff like that, right? There's no reason we should buy that software. We can definitely do all of this with Robot. We've done Robot for 2D analysis in structures for years. And to apply these edge loads, again, it's an issue of, it's not actually an issue of applying the edges, right? It's an issue of, if I want to apply an edge load in Robot, I got to go over here, and I got to click this, and I got to click, you know, this, and then I got to apply, and it's all a bunch of clicking, and then it changes, blah, blah, blah. But really, a lot of what you're doing is rule-based. So if there was an opening in this guy, you know, the opening, potentially, if it's a spider opening, is actually just automatically going to get a pinned support, right? If that makes sense. So I know, just looking at this will be what we do next week. The support, the hierarchy of information is there's a panel. The panel has edges. The edges have a curve, which is what we drew, by the way. But what we didn't apply was the release or the support. And the support is probably what's going to be what we have to focus on next week, because we actually picked, remember when we did Shift-Control-B and we did panel? And we saw all of these options and we were like, wowza, look at all that stuff, right? Well, knowing now a little bit better what a panel is, in other words, a panel is all of this stuff. If I go Shift-Control-B and I say panel, first of all, I'm not going to look at anything that says BHoM environmental, because environmental, we're not environmental engineers. We're not doing that, right? We're not MEP guys. But if I look at this guy here asks for a list of edges, a list of curves. So we know that actually what we want to do, this still creates a panel, but instead of taking in an outline, it takes in an edge. Why is that important? Because if I go Shift-Control-B edge, I can actually, I'm gonna have to wrap this up. I can actually create an edge, which in and of himself has the curve that we drew, right? But it also has a support, right? So maybe I can just do it real quick. It says constraint. Constraint 6 degrees of freedom. Again, you might not know exactly how to do this yet, but it's actually fairly easy to do. Let's see if it works. So that's the support, and now if I just take that panel over here, let's see if we get one with a, it's a whim, it might not work, but there is a way for us, because we know the code, that the code would work. So we should see two panels here pretty soon. Oh, he's not happy again, right? So we had seen before that he doesn't like it For some reason, it's not having a good time with sending over automatically. Interesting that it does that. We just delete what's over here, and then if it doesn't work, that's what we're going to pick up next week. Live examples, always fun. Yeah, something about robot. So the problem's in robot, because actually my robot's frozen. So as unfortunate that happens sometimes, and I guess we could try and just reset the entire thing. But obviously this is all part of the learning curve, and the most important thing that you take from today is the introduction to the BHoM and the idea of the objects and the adapters. You'll be able to start using this stuff fairly quickly on the job, especially if you already are modeling in FEA land. What we've learned in structures is you shouldn't not use these tools. There's never a real good reason to not use these tools. Let's put it that way.